Hello.
Yes, sir. I request everybody in the audience if they can mute themselves, that would be great. And we will be getting started in another minute or so. Okay, let's get started. Hello, everyone, and thank you for coming to today's talk. I know this was a short notice, but the speaker that we have today would be a great addition to this Quantum Winter lecture series. Miss Dr. Najwa Sidqi, she is a great prospect, like she brings great prospect in quantum computing and has been a well-known speaker in many events that I have personally attended, and it is great to have her here today. So before we get started, I just want to introduce the organizers for this quantum winter event, and then we can hand it over to Dr. Siddiqui, and she can get started on her presentation. So to get started with, we have International Society for Computational Fluid Dynamics from UK, who have joined us and is represented by Dr. Jamie. So, Jamie, if you can give a bit of introduction.
Sure. Hi, everyone. Good evening. As Abhishek said, my name is Jamie, and I'm from the ISCFD. We're a UK-based society, and the goal of what we do is to promote the subject of fluid dynamics, and in particular computational fluid dynamics, to anyone who's interested, whether you're an undergraduate or whether you're a professor. Everybody is welcome to join us. And what we do is we host webinars like this one, specific to CFD, of course. And we invite people from around the world. In fact, today well, just 2 hours ago, we hosted Professor Matthew Juniper from the University of Cambridge. He gave a really, really nice fluid dynamics lecture on printing, like ink going through the printer. So we try to cover a very broad range of subjects. So if you're interested in fluid dynamics, in particular CFD and the simulations, and you would like to find out more and gain more insight into what's going on in this field, please do get in touch. Please join. It's free, and yeah, we hope to see you soon at one of our sessions. Thank you.
Great. Thank you, Jamie, for that. And this is important to mention that Jamie itself would be speaking in tomorrow's Quantum Winter lecture series, and he will be bringing in a very interesting topic of astrophysics and using computational sciences in that. So please register for that also. And so I just want to make sure, is Sam online or anyone from QCI is here? Okay, I don't think so, but okay, we can give a bit of introduction about quantum computing in India at the end of the talk. And just few bookkeeping notes, and then we can get started with the talk. The hackathon, the Quantum Winter Hackathon the overlay has been mentioned. If you are not in the WhatsApp group or the Discord group, you will be receiving an email soon. We have added few more talks, which we thought would be very helpful for people coming into this hackathon. And that was one of the reasons why we have today's lecture by Dr. Sidqi here. So let's get started. And before starting, I myself am Abhishek Chopra, the CEO and founder of BosonQ. We are a young and dynamic startup that is leading the paradigm shift in bringing quantum computing and multiphysics simulations together. So to read more about us, you can visit our website or our social media pages, which I will be posting the link for. But without wasting any more time, let's get started on the talk for today. So first of all, thank you for coming today, Najwa, for this talk. It will be really amazing to hear you out, and really excited and looking forward to it.
Thanks so much, Abhishek, for inviting me to present the Winter Quantum Lecture Series. I'd like to thank the organizing committee of these Winter Quantum Lectures initiatives. I think it was brilliant. I had a look at the different lectures that you had before, and I thought they were amazing. So I'd like to thank BosonQ, the Quantum Computing India, and of course the ISCFD for allowing me to present today. So I'd like to talk about my experience with managing knowledge in quantum general, but also in quantum computing specifically, and what are the different promises and barriers of quantum computing. So I'm Najwa Sidqi, and I'm a knowledge transfer manager in quantum technologies. I'm based in the UK, specifically in Scotland. And I work with an organization called KTN. So KTN is a non-for-profit organization based all over the UK. We're around 200 employees. And we work actually with different organizations like industries, businesses, research organizations, academia, policymakers, government agencies, to create a positive impact for the UK economy, but also to impact the environment and the society. So just a short bio on myself, and just a bit of icebreaker also before we dive into quantum and quantum computing. So I define myself as a citizen of the world because I live in few different countries. I'm also a quantum science enthusiast and also a Scotland lover. So before moving to Scotland, I have received a degree in physics and also a master's degree in material science and nanotechnology, but a bit of specialization in microelectronics and semiconductor from INSA de Rennes. And I have also received my PhD degree in ultra-fast photonics. And I completed my PhD in a company called Helia Photonics, which is based in Scotland. and got my degree from Heriot University, which is located in Edinburgh in Scotland. So I've got a bit of diverse work experience, mainly an industrial experience in microelectronics. So I was a process engineer, then a reliability engineer, a failure analysis engineer, and just more onto testing electronic circuits in my early years of career. Then I worked for large area glass coating in Germany, where I used to be a process control engineer for magnetron sputtering technologies. And then finally, for my PhD, I was more focused on photonics and quantum applications in general. So my career and study options took me into a bit of a long journey. So I lived in 4 different countries and 9 different cities in the past decade of my life. So I want to share with you a small story before we get into quantum computing. And this is the story of a Scottish piper, Karl der Grosse, Queen Mary II, and Mozart. And it sounds a bit odd and unusual. So I just want to share blanks from my life journey and the places I have been to during my career. This is a picture of a Mozart jaw from the Curibga mine. So Curibga is my native city. So I was born and raised in Morocco before I moved to France. And this city is known to be a world reservoir of phosphates, has around quarters of world's phosphates located. And the Mozart actually is an ancient and extinct marine reptile, which is actually extinct for over 60 million years. And my next story is about Queen Mary II. So when I was 17 years old, I moved to a city called Saint-Nazaire. And Saint-Nazaire is actually a place where a lot of cruiser ships, and ocean liners are made. So I got the great privilege actually to visit Queen Mary II, which was built in the Chantier Atlantique. So Queen Mary II is an ocean liner. It's actually the biggest, the tallest, and the widest ocean liner in the world, and also up to very recently, the biggest passenger cruise in the world. My third blank is on Kaiser Karl, or Charlemagne, if you know it. And this is a statue from the city called Aachen, which is based in Germany. And as you know, Charlemagne was a big emperor in the history of Europe. And his statues are present over all the city in Aachen. So it is very beautiful indeed. My first story is on a Scottish piper. So this is a photograph of a Scottish piper on Waverley Bridge. For who are familiar with Edinburgh City, you could see the Edinburgh Castle behind the piper, and also the Prince's Gardens behind the piper. So if you wonder, how did my story with quantum start? And when did it start? It actually started 4 years ago. So this is a picture from my time at Helia Photonics, where I was a PhD student. And I was studying low-loss dielectric mirrors for microcavity applications. So microcavities are optical resonators. And these were fabric barrel resonators that I was developing for several quantum sensing, quantum communication, and quantum computing applications and devices. Actually, 4 years ago, I have received a grant called Marie Curie Fellowship. And this grant aims to train around 50 PhD students to become leaders in specific technologies. So that training network was called Spin Nano, and it aimed to develop several aspects of quantum technologies, specifically quantum sensing and communication. So this was really a great experience where I worked with group leaders in Switzerland, such as ETH, University of Basel, but also QTech in Delft, the University of Constance in Germany, the University of Munich, the University of Sheffield, and the University of Cambridge, around how to make optical resonators for quantum communication systems. So back to our agenda, and now I am a knowledge transfer manager in quantum. I'd like to propose this as a cycle. So I'll talk about what it is, knowledge management in quantum. I get that question very, very often. What do we mean by knowledge and knowledge management, and how does that look like in quantum? And I'll talk a bit about how do I map knowledge in quantum computing. What are the enablers of quantum computing technology, and what's the current landscape like? And finally, back to our initial questions, what are the promises and barriers of quantum computing? So I do manage knowledge, and this is what I do for a living. So I went actually and did a bit of literature review of what's knowledge and what's knowledge management. So there were a few interesting definitions of what knowledge was, but this one was particularly interesting and spoke more to my current role at KTN. So knowledge is defined according to the reference I stated below, is the information that has been improved on and a mixture of experience, insights, reading, and imaginations. It evolves in people's minds by a combination of data, information, and experience. And knowledge management is the process of identifying, capturing, leveraging, sharing, and effective utilization of organizations' intellectual assets to enhance its performance and competitiveness. That doesn't sound too complicated. You can see that knowledge isn't only about having information or gathering data, but there is a big volume of individual experiences and insights. And this is vehicled by people. And it's evolving in time. So knowledge is dynamic and information is static. Data are static. And knowledge management is the process of capturing that knowledge, but also sharing it in an effective manner that can benefit to organizations, to businesses, so they can grow and be competitive. So this is also a very interesting diagram I found in that reference, which is a tripartite of knowledge management. You have knowledge management, and you have on the top people, because people are the vehicle of knowledge. Processes are the different things by which knowledge is transmitted, is shared, is enhanced, and the systems are the ways by which knowledge is being managed. So in my day-to-day work, I actually a lot of actions. I have people in my main focus, especially in quantum technologies. So I do talk to a lot of people who work in businesses, who work in research, people who make policies, people who fund research, people who fund businesses. I actually gather all these information to make them in a digestible format. So I use a lot of processes also to share these information. So some of them is I do run a lot of events to raise awareness about quantum, their applications for end user sectors. I'm most importantly concerned about how quantum technologies will impact not only the global economy, but also how they will impact our society and our environment, and how quantum sciences can serve us to solve some current issues. And I also use other processes like mapping knowledge in quantum. So recently I have launched the UK Quantum Landscape, which maps actually the current capabilities in quantum technology, specifically in the UK, whether it's businesses, currently funded projects, and the public funding landscape, the research groups and institutions where quantum sciences are being developed, the national centers or hubs where we have a big reservoir of skills and capabilities to enable quantum in the UK, and also the training centers or the postgraduate training centers to form the next generation of quantum scientists and engineers. So I will share a link at the end of my presentation on this quantum landscape map where you can go and explore it. I know, and I was informed that a lot of people on this call are also graduate students, so it may be useful for you to go and check the businesses list if you're also looking for or to connect or collaborate with a research group in the UK, or find a PhD opportunity in the UK or postdoc opportunity in the UK, then this could be a useful resource for you as well. So just a blink of what the landscape map contains, and I focus on quantum computing, and because it is an interactive map, you can filter on the capabilities or the main areas of expertise in quantum computing. So here I have a tight list of around 20-something companies based in the UK. So you could see already some familiar names shining from that list, and some big names of quantum computing like Cambridge Quantum Computing, D-Wave Systems, Honeywell, IBM, Microsoft UK, Hitachi, Oxford Ionics, Riverlane, Rigetti, Raytheon Systems, RACO, CQC, Tundra Systems, etc. So there are also some quite multinational companies that are based there. And you could also see that they have a color code by which they're represented. So they're either technology providers or technology developers, or an innovation support organization, or an end user, or consultancy. They could be several of these at the same time in the landscape. So it is a quite diverse landscape. So at the same time, and while I did the exercise of mapping quantum computing in the UK, I sorted it with keyword lists and capabilities. And these are the sectors or the keywords that always came up and that were associated either to end users or to technology developers at the same time for quantum computing specifically. So these are the adjacent technologies and end users of quantum in the UK. So that includes artificial intelligence, telecom companies, high performance computing, automotive, digital, technologies, IoT, 5G, geospatial navigation, and machine learning. So maybe these don't come as a surprise to you. They're very tightly related to quantum computing. And they're also pushing to speed up the adoption of quantum computing and the industrialization of quantum computing, and probably what will decide the next steps of the quantum computing revolution. I did also a bit of summary around the current landscape for quantum computing. So there are different ways to enable quantum computing. So the most common one is that chandelier-like type of quantum computing or superconducting computing. So people like IBM, Rigetti, D-Wave, Google, Oxford Quantum Circuits do superconducting. You have another way, which is integrated photonics. And examples are Xanadu, PsiQuantum, Tundra Systems. You have trapped ion technology by Honeywell, IonQ, Universal Quantum, which is a spin-out for the University of Sussex. And you have other ways. Some of them are hybrid of all the previous ones. And some of them are topological quantum computing, like Microsoft, electronic gates, like Universal Quantum as well, optical AI chips by Optalizes, which is a spin-out from the University of Cambridge in the UK. So there are several ways of making a qubit, and there are also several ways of enabling quantum computing. So quantum computing, and have already background of why quantum over classical. And if my assumption is wrong, I added some learning material at the end of this presentation, which is my favorite learning material for quantum computing. But these are the main promises quantum computing has for industry. So the first one is reduction in the power consumption. So quantum tuning is expected to result in 100,000 reduction in power consumption. That's huge. And you know, for electronics, power is really, really critical element. Okay. Okay. I can see move. Okay. The second one is enhance computational problem-solving speed. So we have an example of the SA30 qubit quantum computer. This is a bit of an old one because now we know we can do more than 30 qubit quantum computer. But only 30 qubit quantum computer can run trillions of operations per second. So this is a huge value, especially for solving big problems. As we live in a big pandemic and have so many interfering elements in our economy, in our environment, if you imagine that you want to know everything about how COVID can impact our life, you will need really some very powerful computational and problem-solving systems to handle large amounts of data that you would have gathered from the current pandemic. So that's all power and calculation power. And the third promise is increasing data storage capacity thanks to the quantum property of superposition, because you know, one qubit can take an infinite number of values between 0 and 1, while the classical bits only 0 or 1 at a time. These are the main promises that are so valuable about quantum computing. So I have also gathered from the knowledge mapping a list of sectors that are currently actively looking at quantum computing. So some of them are aerospace, defense and security, clear sector, environmental studies. As you know, topics like decarbonization or biodiversity are very relevant topics and important topics in the current environmental studies. Other sectors are forensics, logistics, privacy also, or cyber and data security. Two principal sectors also chemical simulation and computational chemistry, materials, drug and drug discovery, very relevant in the current situation. But also, a lot is related to artificial intelligence and machine learning. And of course, there are more than what I could put in a diagram, which is a potential end user for quantum computing. So, thinking about barriers to quantum and why does it take that long to be adopted by the economy, but also by the society. And to me, barriers to quantum computing are not noise, error, stability, bulkiness, not being able to operate at room temperature conditions, or even stability. As knowledge transfer manager in real barriers to quantum computing are the lack of knowledge about the value of the technology by several end user sectors, and also the sparse efforts in community building. And building a community around quantum computing is very important. How the efforts in, let's say, the global landscape are very sparse. They're not united, and the efforts are not united in making one community for quantum computing. There is also, I've noticed from so many interactions I had with people I speak to, a lot of awareness about quantum societies, but also policymakers and governments. And this affects the education and training paths, which will affect the skilled workforce quantum computing. It will also affect the research base, the access to finance and funding opportunities, but also the overall diversity metrics in quantum, whether it's the diversity of the industrial landscape and who are the main stakeholders in quantum computing, but also the ethnic and gender diversity metric in quantum. Finally, and because I wish I knew this before, but I'll share it with you. That's the purpose of these lectures. Quantum computing is not only about coding or computer science, but also mathematics, thin film fabrication, material science, cryogenics, vacuum, electronics, optics and photonics, mechanics, and many more. So there is a place in quantum for everyone. So get involved and be part of the next quantum revolution. Few tips before you join that quantum adventure. My first tip to you, it's okay not to know or understand everything about quantum because no one does. Second, if you think you do, think again. My second tip, you can be part of quantum at any time of your career. My fourth tip, keep your mind open about new opportunities. So congratulations, you're all set and ready to embark on the next quantum experience. And that's from me to you on quantum computing. I have put a list of some of my favorite learning picks on quantum computing. Sure, just to introduce yourself about what quantum computing is, what's the benefit of it, a bit of basis on quantum mechanics, and also difference of quantum over classical computing is quantum computing for the very curious, which is a very good one, and the future of quantum computing. Marie Curie, Director of Research at IBM. So it's a 30-minute YouTube video, very concise and also very educative. Quantum computing with Andrea Morello, Professor Morello, who is a professor at the University of New South Wales. And it's also a very nice one. I put the most recent of his videos. He's got plenty on YouTube as well. And quantum computing explains one concept in 5 levels of difficulty, available on YouTube, and they're very nice learning and on quantum computing. So finally, and this is the end of my presentation, I put your link on the quantum landscape map, which is now available under complete open access on our website. The contact of Quantum Technologies Innovation Network, KTN. So we have our website. We have also a Twitter account and a LinkedIn account if you want to follow us. And my email address if you wish to contact me and follow up. And I thank you so much for your attention. And I think we shall open up for your questions.
Thank you so much, Najwa, for that great introduction to what the current landscape on quantum computing looks like, because I feel the audience that we have gained until now and are related to BosonQ side as well as ISCFD or Quantum Computing India, for them it was a good introduction to see where the global picture of quantum computing lies. So thank you for that. And we would welcome any questions anyone has from the audience, and we will actually spend like 20 to 25 minutes addressing any questions that you would have. So please feel free to text in the chat, and then one of the representative from the organizing committee would take up the questions. Okay, so let's get started. So, okay, so the first question that we have is, what would be the best place to perform hands-on in quantum computing apart from IBM Qiskit?
You mean like a coding platform, or I'm not sure to know what's the scope of the question.
Yeah, I think so. It is. It might be like on the lines of coding. Like, yes.
Oh, I'm not sure if I can help with that question. because I'm not a coder myself. I'm more on the physics side of quantum. So I'm not sure if there are any other initiatives like the KISS-KIT one. I've seen a few courses which I can share with you perhaps later on CERN, for example, which fits a quantum computing course. So there are actually a few of them I have spotted. There are free quantum computing courses. I've seen IBM also has recently launched another free online quantum computing training. So a few of them and some challenges. I've seen some people completing some quantum computing challenges also at LinkedIn. I have to get my head over this as well.
Okay. Yeah, I think so. One of our organizers, Quantum Computing India, they also have courses as well as they conduct some kind of like lecture series or anything that will be helpful. I don't think so there's anybody from QCI I don't see in the call, but if somebody from the organizing committee can post up their link, that will be helpful. I think so. Other than that, yeah, there's Quizkit is doing the best right now in terms of providing education in quantum computing, I would say. So, okay, the next question that we have is what is most promising quantum landscape out of superconducting / ion trapped or other?
Oh wow. Okay. I don't know why I get asked this question often. I'd like to take a neutral part on that. And I think at some point, eventually, we need to agree on what is the best platform for quantum computing. They all have their advantages and drawbacks. And I think some companies or developers has already taken a leader position for quantum computing, as you know, IBM, who is doing or more focused on superconducting. But there are other promising platforms, for example, for integrated photonics, because they operate at room temperature, they're more scalable. So the silicon platform is also something that is currently being looked at. So I think eventually these efforts will be put together at the end to come up with the best quantum computing solution.
Yeah, that's great. One thing, if I can add to that question also, is that it is important to look about the pros and cons of any quantum architecture from its application point of view, because application helps you to understand where do you stand with the technology, like in near term or in long term. So like Najwa mentioned here, every technology has its pros and it has its cons. So if you come with an application, a certain application, you would better be able to understand those things and can choose your prospects based on that, instead of like comparing all the different architectures. It's like iOS versus Android. Still we have the debate which is better, but some prefer iOS, some prefer Android. So yeah, that's I think so a very good answer. So next question is, are there any platform to learn hardware of quantum computing other than EDX?
Not sure. I guess I'll have to take that question with me to have a specific look on that. I'm not sure if this is something that will be looked at. So we have currently in the UK something called the National Quantum Computing Centre, which is due to be handover by 2023. So it will be a sort of toll for capabilities for both the hardware and the software in quantum. So maybe there is something that is currently in the pipeline that I don't know about. But yeah, I'm not sure for the answer for that question.
Okay, yeah, that's. I'm also trying to think because there is resources on quantum computing implementation and everything, but quantum hardware is a interesting question because I mean the best way to learn those kind of things is two places. Either you are a researcher in academia and working with a professor who deals with quantum hardware, or you are in a company like the ones that are making the hardware. I think so. That's the best I can think of. Let me see if there's somebody in the audience who I know who can answer that.
Yeah, I guess it's like you said, there are some specific training hubs. I know, for example, in the UK, we have a hub called the Quantum Computing and Simulation Hub. So they look specifically also at the hardware development. But this sort of training you sort of get with internships or while you do your PhD on a specific research topic, or if you work at the development of the hardware and in a specific business which is looking at developing quantum computing. However, I've seen online and on LinkedIn specifically, a lot of quantum enthusiasts and quantum scientists do these sort of outreach material on explaining or breaking down the architecture, and there is a mention on the hardware aspect. But I think I have mainly a background in coding, so I'm not sure if there are many out there who are working on physical aspects of quantum computing that do a breakdown of this stuff for a larger audience.
Yeah, I see. Yeah, so I think that it will be helpful or like addressing more questions which are similar and maybe we can find more answers to that. So the next question that we have is, there's a person in the audience who has bachelor's in physics and master's in software engineering and works as a software developer. The person is interested to pursue quantum computing but don't know where to start. Do I need a PhD, or is there is there another way to learn and do meaningful contribution? Which I think is a very good question and I think so you will be the best person to answer this one.
Yeah, I do actually get this question also very often. I remember I got this question a few months ago when we were in complete lockdown mode. Was it in April, I think, or May, from someone who emailed me to ask the exact same question. I wonder if it's the same person. Anyway, I put in my presentation specifically for people who want to engage in quantum computing that don't know where to start. And I put that you can be involved in quantum at any time of your career. There are so many ways to be involved in quantum computing because it's such a multidisciplinary area, and when engineers are people are making or building a quantum computer, you don't have only the people who know how to code or people with a background in a computer science, or even people with a background in quantum mechanics and quantum physics. You need people who know how to do electronics. You need people who know how to do mechanics. You need people who know how or with a know-how in cryogenics or cryoelectronics. You need people with know-how in material science, in thin film fabrication, in mathematics. So there is a long list of disciplines that are involved in building quantum devices. So I was myself thin film scientist and a material scientist, that I was developing something that was useful for a quantum device, including a quantum computer or quantum communication devices, for example. So there is a space and a place in quantum for everyone. It doesn't, I don't think you need to do a PhD, just to go back to your question again, because there is a big need for technicians, for example, and for engineers. And as far as I know, you don't need to do a PhD for that. I personally did enjoy my PhD experience because I enjoyed aspects on communicating what I do and doing outreach for the society and for the public, going on to conferences, doing research, and just pushing myself even further. Also, there are also drawbacks to doing research, and it's a big commitment to do a PhD. So if you want to get involved, there are several training programs, and I invite you to go and check the list of training programs that we put there for the UK, but you can check if there are similar programs in the area where you are based or the country where you're based, just to get an inspiration of the different training routes for quantum computing.
Great. That's a great answer. So just to build on that, if I may, I personally and the team that we started with, we had very little quantum computing knowledge. Like we built it from like courses, but we found something which will be very useful in quantum computing, which like an application of quantum computing, I would say. So there are a lot of different lenses that you can see quantum computing from. Definitely the two broader ones would be hardware and the software side. But even in hardware, as Najwa mentioned, there are a lot of different aspects that you can contribute to. You necessarily don't need to have quantum computing background for that, but you a specialization in physics, microfluidics, and anything, like it could be like whole range which requires this technology to grow upwards. Mind you, we are in 1950s, and Najwa can correct me if I'm wrong, of what classical computers were in back like in 1950s. So it takes time for anything to grow, and to bring everything like a formal education or something. It will take some time, maybe few years, 1 or 2 years, and the big players and the universities have understood that in order to utilize quantum computing or quantum technology in general, you need to educate people first, and that was the sole motto why we started this quantum winter thing. That there are a lot of people in multiphysics simulation community who don't know about or never heard about quantum computing. And there were people in quantum computing who have got interested and has participated in courses and lectures and everything. And they want and to introduce them to the prospect that that multiphysics simulations can provide. So to sum up what I'm trying to say, don't restrict yourself getting from what background that you have. The possibilities that quantum technology provides is endless. You just need to figure your own thing, or what you specialize in and what you can bring the value in quantum technology itself. So with that, let's move on to the next question. Similar to this, similar to the last question, the next question is, the person is undergraduate majoring in physics and computer science. How do I go about things from now to becoming a working quantum computing scientist? Najwa, your thoughts on that?
That's a good question. So the question is about how do you transition from physics to quantum computing, if I understood correctly.
Yes, undergraduate majoring in actually dual major, so physics and computer science. So how can that person go to become a quantum computing scientist?
I would say first, I'm not sure the context of your studies, whether you're looking at computer science and you have some sort of knowledge already or some sort of basis on quantum computing. I can speak just from a personal experience, and I really hope that it will just inspire more students on that call, or more undergraduate students on that call, because I went through a little bit of strange changes in my career. So I first started with physics, and I went microelectronics, and from microelectronics did a large area glass coating for automotive, and then back to quantum and photonics. So I know that these transitions can be difficult because you feel like you have to start it from scratch. You need to upgrade yourself to a bit of basic knowledge about the new areas you're working on or the new sector you work on. So I would recommend that go for the positions that match your skills and your profile. So within that quantum computing area, don't force yourself to become a new profile to work in quantum computing. If you already have that skills in physics and computer science, they're already valuable out there for a specific position that could work in quantum computing. So just try to find something that matches as much as possible your current skills and profiles. So this transition is not too harsh. And then you can upgrade yourself into learning more stuff specifically on quantum computing. Your current knowledge or skills or degree are already good enough for looking for these specific skills that you already have. I wonder, does that make sense? Is that helpful?
Yeah, I think so. That was a very good answer, and that should be very motivating for all those people in teams who are in similar position. So the next question is again, I think so, from a student or working professional. He says that I'm from a mechanical background and I find quantum complex and hard enough. How to figure it out, like a roadmap or something. So that, I think so, that is what you presented in the last slides of your presentation. So if you can build on that, maybe.
Yeah, well, it's just fascinating how many free online learning and educative material about quantum there is now. There's just so many things. You have YouTube videos, you have free courses, you have now free courses by big companies like IBM or even CERN. You have Qiskit, you have so many free online tools that you are able to access, and the tools are also the different learning levels, so you can learn at your own pace. This is said because, and just give a shout out to mechanics, because precision mechanics are very relevant to quantum. So I remember when we were building the Fabry-Perot cavities, we use very precise mechanical setups to sort of get this micro positioning or even nano positioning of the two mirrors parallel together using these piezoelectric stages. So we can get something that is aligned perfectly. So this is a big branch of mechanics that is looking at quantum, and there are companies that specifically design very, very expensive systems for experiment benches in quantum specifically. So you may want to look at, just to familiarize yourself about what quantum experiments and science is about. Just start from the area you're more familiar with. Don't try to start from what solid state physics is and condensed matter and bosons and things like that. You don't have to go to that most difficult stuff, but you can just look, like, for example, what's the use of mechanics in quantum, and perhaps it will be just one tie for you, and you can start learning more and building more and see, like, how do we build experiments, for example, quantum experiments in the lab and things like that.
Great. Thank you for that. So the next question is a bit on the technical side. Could you throw some light on how is the working going on with handling qubits at normal room temperature?
Oh, wow. I'm not sure if I'm best placed into answering that question. I think the best placed people are people who handle qubits at room temperatures, if that makes sense. I did put an example of a company or a few companies that are working on integrated photonics. So maybe worth looking at these companies to see how they actually look at running quantum computing at room temperature. But I'm not sure of the answer, I'm afraid.
Okay. I hope that helped the person who asked this question. So the next question is, quantum computing is getting very promising. The technology is getting promising as the days goes on, and many people may not have in-depth knowledge. So how do the people in industry recruit? Like, what do they look for? Like, is it a PhD that you want or something else? Like, I think so. That's a very good question.
Yeah, that's a good one. Actually, I will be running a workshop next year, early 21, on exactly that topic. What's industry looking for in the next workforce? And I think industry is looking for skilled people who can build systems, who have that specific knowledge and know-how on quantum systems in general. So there's a sort of mismatch about what the industry is aiming for and what's already available skills, and where to find these talented people or the people who have skills, because there is overall a shortage of skills in disciplines which are not only quantum, but also the disciplines I stated in my presentations that are related to quantum. I think this applies to any other industry, and you have these job profiles that look, very ideal. They want a long list of skills and also long years of experience that are making just the task more difficult to find the right people and the right skills. And usually the right skills are not available, or they're just hard to obtain. so a sort of chicken egg situation all the time. Yeah, good question. And to be frank, that the skills that are being advertised for, whether it's specific to quantum computing, whether it's specific to electronics, whether it's specific to cryogenics. But then the question is whether our training systems are preparing. So there needs to be a sort of coordination. There is also a good way is that some companies sometimes are willing to take people with very little experience, and they give them a training period to upgrade them to the required skills and knowledge. So there are some projects or internships that are run between universities and companies. So they get to train people at the same time and prepare the next skilled workforce.
Yeah, that is a great insight. Thank you for that. Just to mention, because I have been on the other side of the receiving end as well. So sharing some experience on the talent pool, we definitely feel that when we were recruiting people for BosonQ side, we did find there is shortage of talent when compared to other fields. And that is because the quantum technology itself is very, very new. It makes a lot of sense that people are trying to do a lot of things and trying to gain as much experience as they can through small courses, through internships. And I think so for the near term, I would say next 6 months or a year or so, this will be the main mode of how you will get acquainted with quantum computing. It is important that industry and the academia together partners up, and we ourselves are trying to do some of those things. Like we are trying to make some connections or like partnerships along with academic institutes, so that we can have a dedicated course towards quantum computing. And that should be something which is open for all. It's not just that you are a student at that university, but something which is much more broader. And that's where it is important to understand we just not need people who can do things in quantum. It is very important to understand that we need people who can take and be that leaders who can teach others or train others in quantum itself, because that is the most important thing that is needed right now, looking at from an industrial perspective. In terms of the skill set that you need, I think so if you're specifically on the software side of things, it is not difficult to learn a a coding language. But what is important, really important, I would say, is algorithms. Can you think different? Can you do something different? Can you just take the computer science knowledge that you have, even from classical sense, and design or redesign algorithms? I think so that will be the most important skill set that people in the software side of things will be looking at. In terms of hardware, you don't necessarily, and I am not the best person to speak on the hardware side of things because I've not dealt with it, but my 2 cents on things would be a core physics person or a computer architecture person can be very helpful too in that. Just that you need that background in like quantum realm, I would say, a bit of background so that you can take your classical computing skill set and apply that in quantum computing. So I hope that helps the audience in large. So we have few more questions that we can take now. This one would be, can we exclude CSE, which I think so is computer science and engineering, from the core research in quantum, or is there a need to be interdisciplinary?
Sorry, can we exclude? Could you repeat that for me?
Yeah, can we exclude computer science and engineering from the core research in quantum, or is there a need to be or there is a need to be interdisciplinary?
I think there is definitely a need of being interdisciplinary, and I just want to make sure that the question is meant by interdisciplinary or multidisciplinary. So multidisciplinary is quantum computing because it involves a lot of disciplines, and interdisciplinary because it interacts with other disciplines. And the answer is yes, because I have shown that this diagram where quantum is sort of, or the sort of revolution in quantum is pushed by other areas like artificial intelligence and machine learning and digital technologies and telecom. So it is indeed an interdisciplinary topic, but I don't see why we need to exclude computer science and engineering from quantum. They're already included within it and part of it. So the answer is yes for both multidisciplinary and interdisciplinary.
Okay, so thank you for that. I will take some different questions. So, Dr. Siddiqui, a small out-of-topic question. If possible, can you explain if you prefer Copenhagen interpretation or pilot wave theory of quantum physics?
I'm not sure that's the difference between Copenhagen interpretation or pilot wave theory. I don't think I can answer that. I'm sorry.
Yeah, I'm not even, and I'm also not sure if that is something we can answer ourselves. So that's fine. Okay. So that's all the questions that we had from our chat. Ruth, if there's any question in YouTube live that you had, can you post it up here, or can you maybe speak it out? Okay. If not, I'll just give 1 second to Ruth. Okay, so so one of the questions is, can you please mention some career paths for people from natural science background, especially physics, to work in the field of quantum computing? I think so that has been addressed, but if there's anything more that you would like to add, Najwa, to that?
Yeah, that's a good question. Well, there are many career paths for people from natural sciences backgrounds and biology in quantum in general. For example, in quantum imaging and photonics, there are so many applications, for example, in the single photon technology for healthcare imaging or for in vivo imaging, for example, marine imaging. There is a lot of work going on, and also in quantum computing, that will be drug discovery, computational chemistry, and simulation. So there are different things in quantum for people from natural science background, indeed.
Okay, great. That's great. Ruth, any other questions, or was that the only one? Okay, that's it. Okay, so thank you, Najwa, for that amazing introduction to people about where the quantum computing and the technology itself and the landscape. I think so. It was very helpful for even us to understand that. And thank you for bringing this global perspective to things. And I really like the story that you mentioned initially. So thank you so much for your time and your effort in putting up this presentation for our audience. And thank you for being a speaker in the Quantum Winter event. So thank you so much.
Thank you so much for having me, and thank you for organizing the Quantum Winter Lectures.
Great, thank you. So just for audience, we will be having another talk tomorrow. Same time, the start will be at the same time. We will be from Dr. Jamie Townseed from ISCFD, and he will be talking about astrophysics. Then we have a networking event that we are setting up, and hopefully it will be, the information will be relayed soon. That will be basically making the teams for the hackathon. Next week, we will announce one more lecture, which will be on practical applications of quantum computing, or basically like how do you code in quantum computing and Qiskit. But that has still to be decided, the dates and everything. But we will be again relaying that information. And the last speaker of our quantum winter event would be on December 5th. Jinpeng Liu from University of Maryland in US. So yeah, if you guys have any question, please feel free to text us in WhatsApp or Discord or email us. And I hope you got the link in the text that in the chat that I've sent. Please fill that out. We're going to close that survey soon. It is important for us to know the audience and their background, so we can help them in the best possible way during the hackathon. And more information on the hackathon will be sent out through WhatsApp, Discord, and emails, as well as our social media channels. So thank you everyone for attending today's lecture. And again, thank you to our guest speaker for this amazing talk. Looking forward to more interactions with the community. And have a good night, stay safe, and enjoy Thanksgiving if you are in North America.